Hello and welcome back to another OK Motorsports Siemens NX tutorial. My name is Aiden and today we're going to be going over some wire modeling. So this is a useful tool if you're doing like brake lines or cable routing throughout the race car. This is something that we want to have well thought out ahead of time in CAD. So we're going to show you how to do some just basic wire modeling. So let's imagine that I have, a computer mouse and then it's going to have a cable coming up the front and that's going to go somewhere. Let's say it's to, in this case, a laptop, obviously. But when you're working, let's say, in the master assembly of the race car, you're going to have a point A and a point B, two places that you need to connect a wire. And then you need to route the cable from point A to point B. And I'm going to show you how to do that now. There's actually two different ways to do this. Siemens NX does have a built-in cable routing function, and it's basically just pretty simple, similar to how the surface model works. You basically have a start point, an end point, and it connects the two together, and then you can add some you can snap the line to different points on the car if you needed to go around certain bodies or what have you. But then there's also a second way to do it, and it gives you a little bit more control over everything. By defining the specific curves and bend radiuses and stuff. And that's what we're going to go over today. The way that works is you actually physically trace out a sketch that is continuous that your tube is going to follow completely. This would be better for, say, brake lines because we need to follow it like a consistent path along the chassis, but then also brake lines have things like minimum bend radiuses and stuff like that. So this is probably the way that you would do a brake line tube. So yeah, to start off, I have my computer mouse, and I'm going to model some other points as my point B, which is going to be off into space, let's say over there. So the first thing that I'm going to do is draw a line somewhere off into space. And the way I'm going to do that is by setting up a datum plane. So datum planes are a really common feature that we're going to be using in this technique. And basically, you need to set up your datum planes to be in the right place so that you can draw on them so that your drawings are continuous, they form a continuous curve. So I'm going to try and make this a little bit hard on myself by putting my end point in a really weird position. And that's how I'm going to set up my datum plane. So to start, I will create a sketch just on top plane. Okay, and sketches are probably my favorite way to define datum planes because they're easy to manipulate and they are easy to adjust later on down the road, I guess. So yeah, I'm going to create a line and it will be somewhere around this position. Remember, always define your sketches, so I'm going to have it in a certain position. I'm going to make up some numbers here. The most important thing is going to be this endpoint. This endpoint is the one that I'm going to use to define the plane that I'm going to make. So I'm just punching in some XY coordinates, all super simple. 300, actually about 350, just make it further away. Cool, and then I'll also define the length of my line, which doesn't matter, but I'll do it anyway. And then the angle. The angle is something that I probably will change and adjust if I want to move my plane around. So this will be 30 degrees, let's say. Cool. So then I'll finish that. And then now I can go up to datum plane. And in this dialog box, this is selecting how you want to pick how you want to define the plane. But usually by default, it's actually locked on inferred. This is just going to try and guess based on what you select. It thinks is the way you want to define things. So if I have this on inferred and I just select the endpoint of this line, it's perfectly set that up. So the plane is defined as perpendicular to the line and it's snapped to the end of it. So I'm going to press OK. And now I can pick this plane as something to sketch on. And of course, this is upside down, but whatever. This is the part where I'm going to trace some line that is going to be my end point. So I'll trace it somewhere about there, and I will make it 45 degrees, 45, and I'll also define all the points because, again, it's a great habit to fully define all of your sketches. Cool. Okay, so now I don't actually need these two things because that's just some method that I use to define my initial sketch. So I can come back to them later if I want, but for now I'm just going to hide them. So I'll click on these little eyeballs, hide the sketches, and I'll show this one. So basically, what I'm going to do is have a sketch that comes out of the end of my mouse, so that's my start point. And then I'm going to finish it off by connecting to this line that is over here. So the way I set up these planes is going to affect, like, you know, does it come down and bend up straight away and then loop around here? Or does it come out front, curve to the side, and then loop up and then down? There's a couple different ways that you could do that. So to start, it looks like the best way, or at least the way I'm going to do it to start, is to have it come straight out and then bend upwards and then loop around and snap down. So to start, I'm going to sketch a line coming straight out of my mouse, and that'll be on the side plane, right, I guess. And now, this is probably a really good way to set things up, because you'll notice that this sketch perfectly shows like the angle of this line, and that if I just look at the sketch in this 2D profile, I know that my cable is going to come out here, loop up, and then eventually loop down to there. So I can actually trace everything out in a 2D profile and then drop it down. That would actually be a super easy way to do this, and that might be what I do. Because there is a way to, actually I'll do the combination of a bit of both. There's a way for me to just sketch this in a 2D, and then I would flip to this plane, also sketched in 2D, how it would have come out there, turn, and then go right to there. And then I could extrude both of those as surfaces and take the intersection plane and just make that my continuous line. That's a super simple way to do things. And it is great, but it doesn't give you perfect control over your bend radiuses sometimes. And so that could be a little bit of an issue if you need, say, specific bend radiuses on specific planes. It might be better to set up those planes and then you can draw and perfectly define the bend radiuses. So I'll start by doing that right now. And the way that I'm going to have this happen is it's going to come out the end of my mouse. It's going to curve up on a consistent bend radius, and that curve is going to be on a 45-degree plane. It's going to be kind of going up in this direction. So what I'm actually going to do is get out of this sketch, and I need to make a plane that I can draw on that's on that 45 degrees. So what I can do is, again, I'll use sketches to define my plane. I'll use the front one this time, and I'll draw a line that's about there. My angle, what angle do I want that as? 45 degrees. Again, I'm creating a plane that's perpendicular to this line, so I got to think, in fact, if I wanted to view what that would look like, I can always create another line like that, and then make these two things perpendicular to each other. And now I could kind of, move that up and down and point where I want my line to go. So yeah, maybe I'll make this at a 30-degree angle. Sure. And I'm also going to make this a construction line just so that I don't see it outside my parts. It makes things easy. Lastly, define everything. And I'm just going to make these two lines equal to each other because it's easy and I'm lazy. Sweet. Okay, so I'm going to use the end of this line to define my plane, and I can't see that plane through this body that I have, so I'm actually going to hide it and then bring back that line and snap a datum plane onto this. Sweet. Okay. And then I'll bring back that body just so that I can see it. And now I can't see my datum plane, but it's okay. I can go select it in my item tree. Oh, that's editing it. Right click on that, and then you can select sketch. There we go. So now I'm going to draw the starting of my cable. And that's going to be a line that is a certain height off the ground, starting right about there. It's going to be flat. And then it's going to have a curved radius up like this. From there to there, da-dee-da-da. Cool. I'm going to define that as being flat on the ground, just to make things symmetrical. Make collinear. There we go. And now, realistically, these 2 points should be tangent to each other. But I'm going to show you, actually, no, I won't show you. I'll just tell you. If these 2 lines aren't tangent to each other, then it won't let you make a continuous tube connecting these 2 lines. That's when you just thicken this line into a tube that follows the path. So I do need to make these 2 things tangent to each other, and then it would let me connect these 2 things. And then same thing when I go to make a curve, or to draw another sketch that connects to this one, I have to make sure that that curve is going to be tangent to this. Cool. And so now I'm going to define where I want this curve to end. It does look like, oops, my curve is kind of over here in this region. So what I'm actually going to do is I'm going to make this come off straight upwards. So the way I might define that is by creating a line like that. And this line is snapped to be vertical, and then I'll make these 2 lines tangent to each other. Okay, and now I've got a curve that's doing that. I also want to define my lengths, make that 50. Sure. And then this will be my minimum bend radius. So for break lines, I believe it is 60 millimeters, so I'll put in that. Actually, I think it's less than that. That's okay. Oh, also, you can see that I forgot to define the starting point of this sketch. So I'm going to drag that out here. I want this to connect to the front of my mouse, so I'm going to include this sketch. Include, okay. And now that's created a line that I can snap to. Make coincidence. Okay, and then lastly, we've got a line coming off here that's got to be defined. And I'll make it 40. So my tube is going to come off at this angle. It's going to jump up and then jump back down there. So I got to figure out how I want to connect the 2. I'm actually going to make a flat plane just to be more in line. I'm going to have it come up here and then go across the bottom and then start to drop down, I suppose. Yeah. So now I'm at the point where I'm going to be breaking things down into like the actual paths that they follow. So basically, I know that I want to plan to have a line or a plane right here that I can snap to, and I can actually use this sketch to snap a new plane. So I'll finish. And then datum plane, I want to snap it to this point, but right now it's making that perpendicular. I actually want to make it parallel to, say, this Z plane. So if I click on that Z plane, it knows that, okay, now I'm defining it parallel to the Z plane and then just on the same coincident with that point. So now I can press OK. So now I'll go in and sketch this. And it's upside down, but that's okay. And it's at this point that I'm going to use a little bit of, I'm going to use that surface extrude method that I talked about earlier, just to show you how it's done as well. So I could do this entirely by drawing some planes and then drawing my curves and then going around and then like basically, it would use a lot more planes, but it would give me more control over the bend radiuses. But in this case, I'm just going to have bend radius, or I'm just going to have a line that comes straight off, curves down, and then curves, and then connects with that endpoint. So use your line, and again, make sure that you're tangent with this line. In fact, I've got to include that line so that I can make a tangent. And instead of a line, I'm just going to start my arc. And you can see the tangent symbol is showing up. That means it's already creating that relation for me. And the next thing I want to do is a horizontal line that I'll make tangent. Oops, that was the wrong, that was perpendicular. Cancel. Select the two curves, make tangent. The curves can only be moved if the stationary curve is allowed to move. Do you want to keep this solution? Oh, I see what's going on. So basically it's asking if permission to break the original mate in order to create this. It doesn't actually have to break the original mate in order to do this. This is just NX being annoying. So I'm going to press OK and see how things aren't, like I could still grab them and, oh, maybe it is leaving that tangent. Yeah, so if I start defining things, make that 60, and this will be, I don't know, actually I'll leave that for now, because I'm also going to include this line, okay, and then create another arc that connects the two. I'm going to make these two things tangents. I don't know why it keeps doing that. Or why I did that. Interesting. Because the length of this should, yeah, it can still adjust, so it should be able to snap those two things. Okay, this is NX being annoying. Why isn't it? Okay, maybe what I should do is have a point. Yeah, the point can snap to the end of that close. And then I can snap my curve to my points. Coincidence. And then I can make the curve and the line tangent to each other. There we go. And that's looking, oh, I know what's going on. Okay, so the height of this curve is slightly different, so I need to add a little bit of a tail to that. So I'm going to relax this coincident constraint. If I can find it, that's the tangent relation. I'm looking until the coincident constraint, there we go. So I'm going to click on it, and it should turn pink. Come on. Ah, this is annoying. Yeah, I'm gonna wait till that coincident mate turns red, but, oh my gosh. I'm just deleting things at this point. There we go, delete that coincident. So now my plane can do this. Come on. It's still there. There we go. So yeah, you have to click on it to make it turn pink, and then it goes. So basically, now this whole line can move up and down. I'm going to make sure that this one is snapped. To the end of this. Maybe again, I have to drop a point on that so that it snaps properly. Close that point. To that point. Oh, come on. There, point to point. Make coincident. Okay. And this was the little bit of a gap that was causing me issues. So again, I'll just create a line that goes between those two, and now we're good to go. Okay, finish. So I created a side profile, and then this is also going to curve that way. So what I can do is then create another sketch, and this sketch, I'm just describing the horizontal relationship that this has. So I'm going to go to sketching onto my top plane. It doesn't have to be parallel to, just because of the way I'm doing this, I'm going to extrude it up. So this can be anywhere as long as it's parallel to the top plane. So I'm going to use the top plane. And then this is where I'm going to include I'm basically drawing the profile from this view, and then I'll extrude them both together and take the intersect. So I need to know exactly where this point leads, which is the point that I drew earlier. So I'll include that point. And again, make sure it's that point. Okay. And now I could have this come off straight, or I could have it curve, or I could have it curve later. So yeah, what I'm going to do basically is have it come straight off, and then I'll probably have it curve this way, and then snap to the end of that. So I'll include this as well. There you go, I've got two lines coming off. I'll connect them both by curves, nice and easy. Tangent, okay. 65, there we go. Everything's fully defined, so I'll finish. So now, what we're gonna do is extrude these lines upwards as surfaces. I can hide this plane, ooh, not the whole plane, or not the sketch as well. There we go. So, we're gonna go up into surfaces, and then extrude creates a feature by extruding section along a vector. If I click this, I'm pretty sure this is extruding a surface. Select curve. This is my curve. Yes, it is. Okay, so I'm going to extrude this surface upwards. Doesn't matter how much, as long as it's taller than this curve. So about that much. Okay. Solid tool body is required for current Boolean option. Oh, I have to select the current Boolean option. None. Okay. There we go. And then the same thing is going to happen with this curve. So I'm going to select that curve, extrude, none. And again, I have to be totally encompassing this curve there. So that'll work. In fact, I might even go a little bit backwards as well. 25, negative 25. There we go, just to make sure I'm fully encompassing both curves. Okay, and now, so what we're doing here is basically saying that our pipe is going to follow the intersection of both of these curves. And you can see how at the end here, our curve isn't going to be consistent radius. This is what I was talking about earlier, where you don't have control over those radiuses in 3 dimensions. But that's okay, I'm just gonna continue on to show you guys how this works. So for now, I will hide this curve so I'm not confused by it. And I wanna get the intersection of both of these. Okay, so again, we're gonna use one of those tools that I don't actually know where to find it, so I'm just gonna go up here and type in intersect. And it's this one right here, intersection curve. So super easy to use. Basically just select one face and then another face and it gets the intersection. My first face is this one and my second face is this one. There we go. And you can see it's already generated a curve along that. So we're gonna press OK. And then, yeah, we're basically done. I can hide both of those curves. And I'll hide this one as well. And now, would you look at that, there's a totally routed wire going to our extremely difficult to get to finish point. Cool. And so now for the final step, we're gonna turn this into a wire. So if you go over here and I have it set in my window at home, but not on this shop computer. More gallery. All right, you know what? I'm just going to go back up to here, and you're going to type in tube. There, it's this one. Call it tube. And then select a curve to draw a tube on. You select your curve, and boom, that's basically it. Outer diameter is going to be something bigger than that, so do like, what does that look like? Okay, there you go. So that's what a 22 millimeter tube looked like. But yeah, there's lots of different ways to draw your curve as long as they are completely tangent and completely continuous. If even one of these points wasn't perfectly continuous, then it wouldn't draw the curve. So in order to describe that, I will draw a sketch on this line. Going to have that tube. There, so this guy. So if I drew another line off of this line that I include, and I make that tangent, that's all fun and games, but then I make an arc that, isn't tangent. Finish. Then this tube isn't going to work. The tube's still there because I made it before trying to add that line. So in order to fix that, I just have to click on this and drag it up above my tube. Now I can edit this tube, including that line. So I'll go over here and then select curve. I'm just going to actually deselect it and then reselect it. And now you can see it's including that little tail part of the line, but it's not including this last part because that's the part where it's not tangent to. So yeah, it's only going to make something up into there. But then if I go back in, make these two things tangents, now it adds it. So if you run into that problem, that is the first thing that I would check. So yeah, hopefully that helps you guys being able to route wires and cables and stuff. And I will see you in the next tutorial, which is going to be on assembly models.